This problem is under Unit 1 of Computational Mathematics, and this is a 5-mark question for the exam. The question is, find the real root of the following equation: f of x is equal to x cube minus x minus 1 equal to 0 using bisection method. And in this question it is mentioned to carry out only 3 iterations, so you don't have to do it full. While solving in the classes, we have done many iterations till we get the constant value of x, so that is not needed here. This will save a lot of time. Sometimes they may ask for 3 iterations, sometimes they may ask for 4 iterations. Accordingly, you have to solve the problem. So first write the given equation, that is f of x is equal to x cube minus x minus 1 equal to 0. You don't have to write here. Now the first step is to start assigning the value of x, this x, as 0. Then in the next trial it is 1, and in the next one it is 2, and you have to go on doing this till you get the f of x value as negative, and the next value of f of x should be positive. So one value should be negative, another value should be positive. You have to go on continuing till you get this. So we will start. So x is equal to 0, let us take in the first trial. So this x you have to substitute as 0. Wherever there is x in the main given equation, you substitute it as 0. So it becomes 0 cube minus 0 minus 1, and when you solve it you get this as minus 1. So continue for the second trial with x is equal to 1. Again do the same thing. Wherever there is x, you write it as 1. So it becomes 1 cube minus 1 minus 1. So the answer here is minus 1 again. So continue. If you have got this as positive, you could have stopped. Now you got it negative even for the second trial also. You continue again by taking x is equal to 2. So f of 2 is equal to, so wherever there is x, you write it as 2. So you get 2 cube minus 2 minus 1 equal to 5. Now you got the value of f of 2 as positive. So previous one was negative, now you got it as positive. So you stop here, and now you have to identify the values of a and b. So what is a? The value of x for which you obtained f of x as negative, that is 1 in this example, that becomes a. So a is equal to 1, and this value of x, what you got it as 2, so that you got the value of f of 2 as positive. So that value of x you write it as 2. So a is equal to 1 and b is equal to 2. Now you draw a table with the a first column, in the second column it is b, third column x is equal to a plus b by 2, and the fourth column is f of x. And as we have calculated, a is equal to 1, b is equal to 2. So you get x is equal to a plus b by 2, that is 1 plus 2 by 2, that is 1.5. So when you substitute it in the again same equation, x cube minus x minus 1, now you use this x as 1.5, and you substitute here wherever there is x, substitute, write it as 1.5. So 1.5 cube minus 1.5 minus 1, you get it as 0.875. Now you have to understand a concept to go further. The concept here that we are using is, there are two concepts. Sometimes you may get f of x positive as we obtained here. Sometimes you may get f of x as negative. Suppose you get f of x as negative, then you should remember that x is equal to a. And if f of x is positive, then x becomes b. So in this first iteration, we got f of x as positive. Therefore, this value of x, that is 1.5, you have to write it under b. A, there is no change, previous one only. So again do with this value of a as 1 and the value of b as 1.5. You find out x, that is a plus b by 2. 1 plus 1.5 by 2 will give you 1.25. Again find f of x, but now the value of x is 1.25 for the second iteration. So 1.25 cube minus 1.25 minus 1, you get the answer with the minus sign. So minus 0.2968. So now you see f of x is negative. So if f of x is negative, what is the conclusion? X becomes a. So this 1.25, that is x, will now become a for the third iteration. So under A you have to write 1.25, under B the same previous value, no change. So again calculate x. So A plus B by 2, now it becomes 1.25 plus 1.5 by 2, that is 1.375. You can stop here since it is only 3 iterations asked. F of x not required. F of x is useful for us to go to the next iteration and identify what is the value of A or B. So here only 3 iteration is asked, so you can stop here. So what is the conclusion now? In the regular problem, actually when we worked out in the class, we went on doing this till we obtained constant value of x. It can be up to 2 decimal or 3 decimal or up to 4 decimal, whatever we can decide. But here, since they have asked to carry out only 3 iterations, just to save time, you can stop here and you can conclude the real root of the given equation is 1.375. What value of x we obtained in the third iteration, you can stop there. So that's all in this video. I'll continue with the next video. So thank you for watching.